Hey everybody, Joe here. Gonna check out a puzzle today. Well, I just did check it out, but what I did also do is mess up my recording. I took a break in the middle because this is a beast of a puzzle, and yeah, I hit the wrong button when I came back, and I stopped the recording instead of unpausing it. It's only got like half of it. So we'll just do it again, and probably take just as long, because it was hard. The rules are normal Sudoku rules. Place digits 1 to 9 once each in every row, column, and 3x3. The four hungry hippos on the edges of the grid are fighting to eat all of the large circles in the grid. If a circle is entirely within the colored territory of a single hippo, that circle will be eaten by that hippo. If a circle is on the border between multiple hippos' territories, which hippo eats that circle must be determined. A number on a hippo shows the sum of all circles that it eats. A digit on a circle indicates how many circles contain that digit. Digits separated by a small white dot are consecutive. These dots are too small for the hippos to care about, so they are not eaten. Not all possible dots are shown. Okie dokie, so there are 36 circles on this grid, which means that if they contained a 9, they would have to be in every single 3x3 box. And if you look down here, you can see that that is impossible, because they would have to be in this row, and they would have to be in this column somewhere, and then they would have to miss a box. So it cannot contain a 9. Therefore, to get to the number 36, it will have 1 through 8 in the circles only. And in this column, there is only one spot for a 9 to go. So basically there's going to be 1 1 in a circle, 2 2s in a circle, 3 3s in a circle, etc., etc. Now if we go down to 8s, 8s will need to be in every 3x3 box in a circle except for 1. And like you can see that it's going to miss one of these, right? Whichever one it ends up being. So for now, we know that these 6 boxes, 3x3 boxes, will have an 8 in every circle. So I'm just going to throw some 8s around, basically in all of these, but they'll be tidied up fairly quickly. As you can see that these will have an 8, so this will not. These will have an 8. Or well, they will possibly have an 8. Okay. And now there must be a 9 in one of these. There's something else with 9s. Or maybe I'm not there yet. Okay. Alright. 9 can't go here on this dot, because it would have to be next to an 8, and we know the 8 goes in a circle, so 9 goes here, or again, it doesn't go by the dot, because we know that 8 goes in one of these circles. So since 9 is blocking here, then 9 goes here, and 9 will go in the middle, and then 9 will go on the top. Okay, now if we were to think about this big blue boy, 87, and we took, I have a little notepad here of all the highest possibilities. So if this was 87 with a possibility of 6 extra, we're just maxing these out. And if these were 4, 5, 6, 7, 8, again, maxed out. And if this was 8 with possibility of 7, 6 for 13, again, maxed out. And then if these two were maxed out with 7, 8, then the grand total, this is 21, plus this big one is 30, that is 51, plus this one over here is 21, which is 72, and these would be 15, which would equal 87. So everything is maxed. So that is 6, 7, 8. This is 6, 7, 8. Whoops. 6, 7, 8. This is 4, 5, 6, 7, 8. And this is 8, 7. But the 8 cannot go here because it's over here. So this is 7. This is 8. Now these are not. This cannot be 8 any longer because the 9 is on the rows and a 7 is in the columns. So the 8 goes over there. So it is not there. It's not here. It goes in this one, or in this column. The 7 now is again going to miss one of these boxes, right? And then it doesn't miss this one. So it's going to miss one of these boxes. Also the 8 misses one of these boxes, by the way. So it goes in on this side of the grid, it goes in every box. And for the 7, it's also going to miss one of these. It can miss one more, however, and it must miss this one. So they're already there. So those will all have a 7 in them as well. And then these 3 so far will have, there will be basically in this little column, there will be a 7 and an 8 in a circle, with one circle unaccounted for at the moment. Now, okay, so these were all part of blue. So they can belong to no other hippo. And then the same type of strategy with yellow if all of these are maxed out, would be the highest two that could go here is a 5-4. So an 8, a 5-4, which is 17. Again, if all of these were 4, 5, 6, 7, 8, that would be 30. If this was 8, I mean 8 with a possibility of 7, 6, which is 13, and then, oops, I'm sorry, I said 8 over there, I'm looking at the wrong note. If this was 7 with the possibility of 13, which is 8, 5, because I don't really remember why that. Anywho, the total on that would be 17 plus 30 is 47, plus 20 is 67, plus 11 is 78. And I think I actually got 79 the first time, because I was thinking if this was a 6, 7, 8, if I remember correctly. But the point is, we're at 79, and we can only lose 3 digits. And since nothing in here was counting as a 3, right, then I can't lose a circle. So all of these are also part of yellow. Okay, and then we have 4 left for green, equaling 20, and then these 6 left for red, equaling 21. Now, if you were to take 8, if you would say, can these be 8, 7, then that would leave 6. These would have to be different digits. The minimum they can be is 1, 2, 3, and then this would have nothing, because you'd already be at 21. So these two cannot be a pair, as in one of them goes up here, either 7 or 8, and then one of them will go down here with a different number. And now to start forgetting things. So with the 20, well, first off, we can do some more down here, because this is a 6, 7, 8 pair. And 4, 5 are in this bunch. So this can only be 1, 2, or 3. And it can't be 9, because an 8 would be here. It belongs in the circle. Okay, so this is a 1, 2, 3, or 4. And now a 5 must go over here. And then these, a 9 cannot be, well, an 8 doesn't go here, because these were a 6, 7, 8 combo. So a 9 can't go here, 9 can't go here, 9 goes nowhere. So these are also all small. This one cannot be a 5 though, because it would need a 6 on one side or the other. This one could be. So we're like that at the moment. But not really, because this makes a 4, 5, 6, 7, 8 combo wombo. So 4, 5 comes out of there. So it could be 3, 4, 5 like that. Alright, so now a 5 couldn't go here either because of the same combo. So a 5 goes on the top. So it comes out of here. Whoops. Comes out of there. It gets marked into there. Also, since these two, right, are 6, 7, 8 only, but they also belong in this clump, whatever they are is going to be up here. But we know that it does not contain a 4. So the 4 also moves down here. But the 4 still has a bit of choice, whether it goes here or up here. So this is also a 1, 2, 3, or 9. This is a 1, 2, 3. Or no, this is only 1 or 9. And then everything else, basically, at 2, 3, 4, 5, 6 will go somewhere in this string here. So it'll be a 2, 3, 4, 5, 6, 8 pair. And these are going to be from all low numbers, 1, 2, 3, 4, or 5. Also, a 9 cannot be on our consecutives, because 8 is in the 3x3 box here in this row of circles, column of circles. So 9 can only go here or here. Also, a 5 cannot go here, because if it did, it can't have a 6 because of this, and it can't have a 4 because we've narrowed it to this row. So this is not a 5, therefore this is the only spot that a 5 can go. And then that makes this our 9, also making this our 9. Okay, so this is 1, 2, 3, 4. And these are 1, 2, 3, 4 as well. This is also 1, 2, 3, 4. And this will be all small numbers, including 5. If this is 4 right here, then you can see that this will have to be 1, 2, 3, and then 5 will have nowhere to go. Because if this was 4, this could not be 5. Can I do anything else with that? I didn't see that last time, actually. 5, 4, 3. And that would be a 2, 1. I guess that would be okay. Okay. Well. Okay. Well, alright. Another thing was that this column, well, I'll just mark them actually. Those all have to be 1, 2, 3, 4, and 5. Right. So you can see that this column is going to complete the ones. Because it's going to have 1 in one of these circles. So 1 can't go in any other circle other than this column. This is going to complete the 2 because 1's going to be in this column, 1's going to be in this column. And then we're gonna be at, for 3s, we're gonna be at a count of 2 so far. So wherever else in the grid gets 1 extra 3. But in short, this cannot be 1 or 2. Therefore, this cannot be 1. 1, 2, 3, 2, 3, 4, or 3, 4, 5. Okay, and then this was, this cannot be a 6, 7, 8 triple, because if it were, there would be 4 cells here that must be all 6, 7, 8. So we would have an empty blank cell, and we cannot have that. The 4 does not go here, because we have it located here in this middle row. So that's going to put the 3 there. This is now a 1 or a 2. This is no longer a 4. This is no longer a 5. So it puts our 5 there. And 8 goes here. I think that was apparent for a while. And that's because 8 is on the right here and the right here. And we know it must go in those because of circles. Therefore, it had to be in this column, and it also had to be in a circle. So 8, we're not sure if it goes in that circle, because it could be up in one of these 2. But it could be in that one, and the last 8 be there. That is also possible. Okay, now on this 3, 4, since we know that it's only these 3, or 4 cells rather, if it was 8, 3, if we think about our possible choices, we need 9 more. So it can be a 4, 5. It cannot be okay, if this was a 3, then we would have our 3 3s. So it could not be a 6, 3. It could not be a 7, 2, because 7's right there. And also 2's are full. And it can't be an 8, 1, because 8's are right there. So that is the only choices if this was 3. If it is 4, we have 12 with 8 left over. It cannot be a 6, 2, because 2's are full. It cannot be a 7, 1, because 7's right there. So it would have to be a 3, 5. So these are only possible to be a 3, 4, or 5. Now, that means that 1, 2, 3, or well, 6 is missing in this cage. 6 is missing in this cage. 6 will be missing in one of these cages. That is 3 cages that it's missing out of 9. Therefore, it has to be in. These are kind of a wild card because we don't know which one it's missing. But it does tell us this. It tells us that one of these must be a 6. And that forms a 6, 7, 8 triple. It also tells us that in these 6, oh no. It was missing 3. It's missing this one, and one of these. So in these 4, there must be a 6 in every cage. So we can go ahead and mark those. And then also this one I hadn't marked yet. And I think that does it. Okay. Now, there was this 21 little red here. Okay, remember I said earlier, it cannot be an 8-7. But we know therefore we know it has to be a whoops. Therefore we know that one of them has to be a 6, right? It has to be 6 and one or the other, because it can't be 8-7. So this is a 7-8. And if this was 8-6, it would be 14 needing 7. Now, if we were to put the smallest digits possible, 1, 2, 3, then we would still need 1 digit. We would need a 1, but we cannot repeat a 1, because a 1 can only appear in a circle one time. Therefore, this cannot have an 8 at all, these two. So it must be a 6-8 combo, or 6-7 combo rather. 8 goes there, 8 goes there, and now 8 has to be in a circle in every box. So it goes there, then it goes here. Does not go there. It's in one of these two. This is not 7 now. Whoops. Not 7. Because of the combo below it, the 6-7. Looking up at it. So that is. And there will be a number in that box. And this is now the 8 here. And now we have 6-7. So we are at 13 and we need 8. We cannot use 4 different numbers because that would be a minimum. That would be 10. So one number must repeat. And it will be here, obviously, because these 3 are in the same column. So if you were to ask if this was 1, 2, 3, because we can only go to 8 and that would already be a 6, and then a 2 could repeat. If you went 1, 2, 4, you're going to be at 7, and then a 1 would have to repeat. We already know that's not possible. If you go any higher, then obviously it's not going to work. So these have to be a 1, 2, 3 with one of those repeating. And again, you could do 3, 3. That's already 6. You'd have to have 2 ones with it. Not possible. Must be a 2. And that also finishes the 2s. This is not actually a 6-7 combo. But I don't think yellow's sorted yet. So this is a 1, 2, 3 though. So this is out of there. That is a 4, 5. And another thing with this one, if this was a 3, then this was 4, 5 here. But the important bit is that this would be all the 3s that could be in the circles. Also though, if that is a 4, then this is a 5, 3. And then again, 3 would be done in all of those circles. As in it couldn't be in any other. So 3 is basically kind of pseudo at its max, so to speak. As in this cell here cannot be it cannot be a 3, it cannot be a 2, it cannot be a 1, it can only be a 4 or a 5. It can't be a 6, 7, or a 6 because of the pair here, but it also couldn't be because it would have been a 6, 7, 8 if you remember, and there's 4 cells. So this is a 4, 5 combo. These are a 3, 4, 5 combo. There is a 1, 2, 9 ending there somewhere. This also is a 3 up here, because it's either going to be 1, 2, 3 or 2, 3, 4. Both of them ending with a 3 up there. And now what do I remember? Nothing? This is also a 2 in one of those. Because it's either 1, 2 or 2, 3. Either way, a 2 is in this column. Which doesn't help me greatly here at the moment, but it will. Okay, now we think of, if this is 3, it gets 1, 4 here. If this is 4, so either way around this goes, these 3 are going to have 1, 4. And then we're going to have 1 here. We're going to have 1 here. Alright. And then this is pretty tricky because, so if the 4 went up here, then it could go here. But if the 4 went here, it could count kind of for both column and row, right? And then it could be 1, 2, 3, whatever, or it could even be like that, you know, something along those lines. So a little bit tricky there. We go elsewhere. Alright, what? Okay, 5. 5 is missing. The 5 is missing one cage. I mean, 1 3x3 of circles. 2. It's going to miss one of these, so that is 3. Maybe both. But so far 3, 4, and 4. Okay, that's it. So 1, 2, 3, and 1 of these. Right? So that's 4 that it's going to miss. Which means, since it can only miss one of these, it must go here or here. Right? So it must belong to those. But also, that told us that it must be in these 2. Which they are pretty well pencil marked for already, but these 2 were not. And that is slowly giving us our grand total of things up here in this yellow Hippos region. And this, I think, could still technically be a 4, but no other digit. As 3 is going to be full because of one of those, one of those, and one of these. And 4, I think, was still a wild card because of this digit here, which could, count for both row and column and be like 1, 2, 3. So we are unsure about that one at this time. There's going to be a 1, 9 somewhere in here. With either a 3, 4, 5, or 6. Now. So a 5 definitely went in one of these. If this was 4, this was 3, 5. Oh wait. What was I saying? It's going to miss one of these. And misses this one, misses this one, misses this one. Right, okay, that's fine. Four. Okay, misses 1, misses 2. Don't know much. Okay. Oh, also, one of these had a 5 in it as well, regardless. But not both. So that is 1, 5, 2, 3, did I say 5's one up here for sure? Anyway, one. Oh wait, maybe don't do it like that. What about like this? 1, 2, 3, 4, 5. Right. Okay. So one of these will have one, and then we can see that basically every other cage needs a 5 as well. So this one needs one, and one of these need one is the point. Oh no, that's not a very good point. If this is 3, this is 4, 5. If this is 4, this is 5, 3. Okay. Nine goes in one of these. Seven. Six goes in one of these, therefore that is a 7. Do I have these fully marked? I think I do now. Alright, also we can revisit our totals. This is still 17. This, if it didn't have a 3, would be 30. This would still be 7 plus 13, 20 maximum, and this could still be 11. Okay, so that's still the same. We basically need to drop 2 value. We're at 78 if everything is maxed, and we need to be at 76. So, what was left? These need what? 1, 2, 3, 4. So 1, 2, 3 is already in this cage. So this is a 4, 9. 4 can no longer go there, making this the 1, 2, making that the 3, making that the 4, making this not. This will now have a 2 in it, you can see. It's either going to be 1, 2, or 2, 3. But this one cannot be a 2. So this one must. This one can't be a 2 because 2's going here. So this one is a 2. This one is a 1 or 3, but then also 3 goes up here, so it must be the 1. This is now the 9, this is now the 3. This is the 2, 3, 4. This is 1. This is 2, 1. These are not full pencil marks, so So, but this is the 1 now, because we got the 9 at the bottom, and the 1 can't go in another circle. This is now, oh yeah, that's a full mark. That is a 5. This is now a 3. The 4 went with a 3, 5, so this is a 5. This is not a 5 anymore. The 3 now goes over here somewhere. Clean up some pencil marks. That's a 4, 5er. 5 goes over here somewhere, and not in the middle one. So that is a 5. 5 must go on the bottom row here, and the top row here. Hey, nostrils are in my way, sir. I want to apologize too. I do think I said a couple good dad jokes in my last one, but since I recorded wrong, I cannot remember what they are, or else I would definitely repeat them for you. I do apologize. Hopefully I'll think of some new ones before my time slips away. 4, 5. We have a 4, 5, 6, 7. I think these are all fully marked. No, I reckon not. I reckon they're not fully marked because... Oh yeah, they are actually. Because 3s are done, 2s are done, 1s are done. So yeah, it is fully marked. So we do have a 4, 5, 6, 7. So in the column, well, we'll do this one too, I guess. In the column is a 1, 2, 9, and a 1 can't go at the top, so a 1 goes here, and then this will be a 2, 9, and the 9 has to be at the top as well. In the middle, this has to be the 2. So that's that. And then, I see, we're gonna have a 2 here now. And then I'll finish the 2s. This will be a 1, 3. This will be a 6. Yeah. And then what do we got left? We got a 2, 7. What'd I miss? A 1. So that is a 2. And this is a 1, 7 combo wombo. That's a 3. This is going to be a 6. It can be a 6, 5. It can still be a 4, 5 or 4, 3. Did we... 5 is down here, isn't it? Yeah. Well, doesn't look like that helped, but it is down there. Does 4 have to go in every other box? Oh, 4 is still a little bit tricky, isn't it? Because it could go... Oh, right. It has to go here in this box. And it has to go here in this box. You can see that because of this 4 here at the top. And we already know that it goes in the bottom. So we know that this one, well, it doesn't matter, this one anymore, because even if it does go here, we know it has to go up in this box too. So that is our 4 count. So this one cannot, or this one, cannot be a 4, or else that would be 5 in the thing. So that's a 6. That's a 3. 4 goes with 9 over there. That's now a 7. This is not. That's not quite there. This. Nope, not quite. Not quite. That's a 1. That's a 3. So this is now a 6. No. This is a 5. That can still be a 4 or a 6. But is this one? Yeah, that is just a 4. This is the 6. This is the 7. So this is the 3. This is not. This is. That is now resolved there. So. This is. What is missing? 1, 2. Alright, and then that. The 2 is below there, so this is a 1. This is a 2. Now the 2 is over here, which is puts it there. I'll get this buttoned up down here real quick. That puts us a 7 there. This is a 1, 9. Looks like 1 can only go there. But yeah. This was a great little puzzle by Scojo. It was. Don't pay no mind about if I did this one a little bit quickly, because I had just done this earlier, and I basically am just doing it back to back here, and it's still taking me almost an hour on my second go through. So this was quite an exceptionally hard puzzle, I thought, but I did enjoy it. Hungry Hippos by Scojo. Try it out for yourself in the link below, and thanks for watching. Hope you have a great day. Bye bye.